Hello everyone. First of all, I welcome you all for this introduction to this Linux session, and I am Prem. I am working in e-Yantra. I've been working in Linux since my college days, and I've been closely working a lot with Linux since last couple of years. And today we are going to see a little bit about Linux and how operating systems are working, and what are the various terms which are used in operating system like kernel, bash, shell, and a lot more. Like we will see those in the next 1 hour, and before that we will move into the presentation right now. Before moving to the presentation, I have a small questions to you all. Like, do you have any idea like what is the common thing between each and everything which is listed over there, like cloud, server, supercomputer, robots, IoT devices, and the containers? Here, the container represents the Docker container, not the container which is there in ship. So, any guess or something? What is common here? Yeah, obviously it is Linux, because a huge amount of technologies which are built underneath Linux, because it is a very nice operating system. Like, because if you see the entire world, like in the software world, most of the technologies which are running with the help of Linux. So today we are going to cover like so many things, including where Linux is mostly used, and what are the various terms which are used in terms of Linux, like operating system, what is shell, what is bash, and what is kernel. There are so many things like terms and everything. I'll cover everything into that, and we'll see how, when we are typing one command in the terminal, how the execution flow will be, how the particular program will be executed, and followed by we will see what is bash. Basically it's a born again shell, what is that and what we can do with that, and I'll show you some live command executions and something. Followed by we will see some small automations, like how we can do our daily task which is automated in a specific time, it can run daily manner, and finally we will wrap up with some interesting shortcuts and things what we can do with like Ubuntu and something. We have been talking about Linux, right? But where and all Linux is used? If you ask me, Linux is everywhere. So, like, for example, when I go to my browser and I am typing google.com, there is a high possibility that this response might come from a Google, like some Linux system, some Linux server. So Linux is there in everywhere, if you ask me, including web servers, cloud infrastructures. Cloud infrastructures in the sense, like there are three main cloud providers. Like there are a lot of cloud providers, but particularly popular cloud providers are AWS, Azure, Google Cloud. Everyone is using Linux, and you might think like when we say Linux, like there is a one developer or the hacker who is sitting in the dark room with a dark terminal, who is with one hoodie, and he's sitting in front of the computer and working. It is not like that. If you ask me fairly, every one of us are Linux users, because one of the best example is Android devices. The Android OS is built on top of Linux kernel. So in the end, if you see all the people who are all seeing in this session right now, you are all Linux users, knowingly or unknowingly. That is the truth, and it plays a crucial role in routers and networking as well. Like Linux plays a huge role in networking part, and Raspberry Pi. Like, believe me, the Raspberry Pi is enough to run the entire Ubuntu operating system. Ubuntu is one of the Linux distribution. Like this, it is a very very lightweight operating system. You don't need a heavy hardware or something to run that entire operating system. Just one single Raspberry Pi is enough to handle each and everything in the Ubuntu operating system. And the robots in robot operating system also built on top of Linux kernel, and the automotive, obviously the cars and other things, we like if you do the instrumentation clusters and things, everywhere the Linux is there. And believe me, the supercomputers, almost all the supercomputers which is there in the world right now is using Ubuntu operating system because of its very lightweight and portability, and there are a lot of uses. So we have been seeing this overall using this Linux kernel or operating system, right? But why everybody is using Linux operating system? There are multiple operating systems, Mac OS is there, and Windows is there, and other operating systems are available. Why people are going for operating system? The main reason people are using Linux is it is completely free and open source. Like we can see the code, and we can literally modify the code, and we can use it based on our need. So that is one of the main reason everybody is using Linux. And it is radically portable. Radically portable in the sense, the kernel which is used in my smartwatch basically, that is the same kernel which is used in the supercomputer which is used somewhere. So it is not exactly same, but basically there is some added features and some added things are there in that kernel, but the core kernel is almost same. And this is like a small tools combined together to run as an entire operating system. The Linux has one code also, I forgot that code basically, but that code is mainly represents that just do the one job perfectly. So together, that multiple jobs together, it will be one operating system. And it is highly tested, and it is totally secure. Because it is open source, millions and billions of developers so far using it, and they are trying to find the bugs, and they are contributing it, and day by day there are thousands of pull requests which has been posted for that Linux contributions, and the team is working a lot to make that operating system more good and efficient. So that is the reason that everywhere Linux is there right now. Yeah, we are into the main thing. So we have been talking a lot about Linux, but what is Linux actually? Most of us are thinking that Linux is an operating system. The truth is, actually, the Linux is not an operating system. It is a kernel. It is a part of an operating system. It is not an entire operating system. Let's say, we'll see the operating system in the upcoming slide. Before that, I'll just say just for now, remember that kernel is a part of an operating system. It was built by Linus Torvalds in 1991. There is a this is a very interesting story behind it. There is a guy called Richard Matthew Stallman, who's the one who started a project called GNU. The idea behind that guy is to build an operating system which is open source. He wanted to build a Unix-like operating system which can do multitasking and multiprocessing. During that process, he built various things like compilers, utilities, and bash, and all the utilities which are required to build an entire operating system. During that time, he started a kernel called Herd, which was they started building it, but it was taking a lot of time to build that entire kernel. So it was in 1980s. In 1990s, Linus Torvalds, he's the like a student like us. He started his hobby project as a building a small kernel, and in 1991 he released that as an open source. During that time, they were ready with utilities, but they were struggling to build the Herd kernel. So during that time, there was a one free software foundation that was also started by Richard Matthew Stallman. So that team find that this kernel is working perfectly fine with the utility. So they together started using, and they build open source operating system. So they initially planned that as GNU Linux. Later that GNU faded away, and people started calling us Linux. So the main thing that I'm trying to say over here is the Linux is not an operating system. It is a kernel. It is a part of an operating system. If you see over here, there is an application and the hardware, right? There is a one thing which is required to communicate with the hardware. there is a program, there is some set of programs which communicates with the hardware when there is some system calls. So that is what the kernel is. The kernel has some set of codes which can directly interact with the hardware. So that is the work of the kernel. So together that kernel, some software utilities, together it is called as an operating system. And also there are with the same kernel there can be multiple different softwares together built, and that can be a distribution. So same kernel, on top of it different utilities, that will be different distributions of Linux. So the one popular distribution that we are using, Ubuntu, and most people might aware about the Kali Linux, that is also one of the distribution. And there are other multiple distributions available like Fedora, Mint, Arch Linux, and much more. Like even some people build some Parrot OS, different. But eventually everything is Linux kernel, but it has various distribution, depends on the softwares and utilities on the top layer. So the kernel particularly do process management, memory management. These terms might be new to you, but trust me, like these are all very interesting topics to learn about. These are some school textbook definitions, like what is operating system. In the sense, people say that is some software that manages the hardware resources, like that is the same thing. Like, and kernel, if you ask me, that is the core program of the operating system that actually talks to the hardware. If you see the core layer, there is a hardware. On top of it, the kernel is the one who will interact with the hardware, and it will give the instruction to the hardware to do some certain task. There is a thing which is required to communicate with the kernel, which is called shell, through which we will communicate with the kernel to tell some instruction, so which the kernel will execute in the hardware. And the application program, it is the topmost layer, which will be we will be seeing, which, and we will see about that in the upcoming slides detailedly when I was walking you through the terminal. Like you will get to know what these things are clearly. So we have been talking about the term called shell, right? So what is shell? The shell is nothing but it just reads the text whatever we are typing, and it will just parse it, and it will find appropriate program which is there in our machine. In our case, it might be some binaries, and it will find that binary and execute that binary in the kernel, and it will be executed in the hardware or something. So the flow will be whatever we are typing, it will go to bash. Bash is one of the shell. So I'll show you a little bit about what is shell basically. I'll just open my terminal. So when I open my terminal, yeah, you can see, right? Yes. So when I open my terminal, if I print what shell which is used in my computer right now, you can see bin bash, right? Right now I'm using a shell called bash. To see all the shells which are there in your machine, you can go to etc followed by shell. Oh, sorry, actually it is shells. So right now there are so many shells which are there in my system, because I have been using for so many purposes. Like bash is one of the shell. There are similarly R bash is there, dash is there. I can use whatever shell that I want. So right now shell is nothing but it just get the input from us, and it will give it to the kernel, and it will execute the output and give it back the response. So basically this is the bash shell what I'm gonna use throughout the session for today. And one more important thing, people might think like today I'm gonna use Ubuntu operating system. So you might think Ubuntu is Linux. Actually Ubuntu is using just Linux kernel. So together Linux kernel, some GNU utilities, and some package manager. The Ubuntu is using the package manager called apt, and also using snapd kind of package managers. And along with that there are other apps like camera and like notepad. So many things are there. Like together everything called as a Linux distribution, that Linux OS basically, that Linux not Linux OS, Ubuntu OS. Okay, so this is same that we were discussing, the base layer will be hardware. On top of that there is a kernel, and there is the Linux utilities, and bash shell is there, and on the top layer which will be visible to us is application. So internally, like if we do whatever the task that we are doing, first it will go to bash and it will go to Linux utilities, and the Linux utilities programs will be executed in the kernel, and kernel will be running those programs and things in the hardware and getting back the results. So today mostly we are going to see like bash and Linux utilities and the Linux kernel little bit. Okay, so when I open my terminal and I am typing ls, so basically it lists all the files which are there in my current directory. So do you know what happens internally when I click ls, when I type ls in the terminal? So that is what which is there right now. When I type the terminal, that ls, it will be shown in the terminal, and it will go to bash. If I go to bin folder, I can see lot of commands. If you see ls is present over there, so if I try to print the ls, I can see the binary file. So this binary file is not readable, but this is what basically internally happening. When I type ls, it will locate the bin folder and it will try to find the binary, and it will execute that binary, and the binary will look for the file system, and the file system will gives us what are the directories and files which are there in the current directory, and also it will go to the disk and find how much memory and things which are utilized for that particular thing. If I do ls-la, you can clearly see that lot of information, like yeah, you can clearly see every details about a particular file or a directory. Who is the owner of the file, who all has the access of it, what is the size of that file, and this is some random this is some large number, right? So to see that very detailedly, yeah, this basically the file, the amount of space it took, and every details are there basically. So that binary will be executed and the result will be shown there. Okay, so when it comes to Linux, the main important thing, one more thing, is the file structure. So when you are using Ubuntu, when you are using a Windows operating system, you might see that C drive, D drive, and so many different disk for different hardwares that we are inserting. But when it comes to Ubuntu or Linux kernel, there is only one file hierarchy, only one root will be there. Whatever the volumes or something, whatever we are mounting, it will be another like tree, another tree leaf kind of thing. So right now I'll just showcase like what are the various file structures are there in Linux right now, and we will see why these things are useful. So if you see, I'm going to the terminal again, and I'm going to the root. You can see a lot of files over there, right? You already aware about the folder called bin. So basically that contains all the binaries, and if I go to home, this is the one which contains all the personal space of an user, all the documents, downloads, all the files which is related to a specific user. In my case, if I go to home, I can list all the users which are there in my system. Right now I am the only one, the Prem is my name, I am the only one, the user. If I go to Prem, I can see all the files which are there in Prem, like documents, downloads, music, some personal files basically. And the etc represents etc. basically, that it contains all the configuration files which are required in order to execute some programs. Let's say, for example, Apache. Like if I go to Apache, if I go to etc right now, I can see lot of like configuration. In my case, I'll just go to Apache right now for showing you. I'm using Apache 2. All the configuration files are there right now. If I go to sites available, I can see all the sites which are there in my current machine. So basically that etc represents all the iteration like configuration files and things, and var basically used for storing the variables like the logs data basically. If I go to var, you can see the system logs and so many things. Like if I go to logs, you see I can see the Apache log also here. So it contains every logs which frequently changes kind of data which can be stored over there. And the temporary file is nothing but it just stores the data for a temporary purpose. Once when we reboot the entire system, the temporary folder will be entirely wiped out. So you have to be very, very careful when you are keeping some data in the temporary folder. And the user folder is mainly used to store the softwares which we are using throughout the different users. So if I go to user, see I can see like this pgadmin is one of the thing like used for Postgres viewer. Like this might be this term might be new to you, but basically just have an idea that it just stores the libraries and files which are used throughout different users, and all the different peripherals, volumes, and everything which is mounted on our system can be viewed in the dev folder. If I go to dev folder, see all the TTY like all the loops in the sense, all the volumes which are mounted, and all the terminals and other things which are connected. And pros basically store all the process related information, all the processes which are running. If I go to rock, I can see all the processes which are running. So you can see the numbers, right? These are different numbers. These are the process IDs basically. This is the command psaux to list all the processes which are running in my system. So in this case, if you see on top, you can see PID, right? You can find the PID in the pros folder. So this contains all the related files and execution programs which are required for that process. So for example, let's take 309. If I search for the 309 here, that is there. If I open that 309, I can see all the files and things which are used by that 309 process. So that Linux file system has everything we can access, and we can see everything. Everything is transparent over here. Since it's a so as I am working on the terminal a lot, you might think terminal is Linux, but actually it is not. Just gives us an interface to interact with the Linux kernel basically. So we have been seeing a lot about that file systems and some basic Linux theories. I'll just show you some commands and things which we can run on our system to see and create files, delete files, move files, and something like that. So the first command that I'm going to cover is ls. It basically lists all the files which are there in the directory. So the main command that you have to learn before ls is man. Man represents manual. So if you want to know about ls command, you can type man followed by ls. it will gives you all the information about the ls command, what are the other flags that we can give along with the ls command. And yeah, in my case, if I do ls followed by lstr a, this is one of my favorite command. Like whenever I want to check for a file or something, I'll run this command because it gives entire information about the directory. So as you see, you can see files in a listed way, in a sorted way, time based, in reverse order, followed by all the files in the sense like A represents all the files in the sense it includes the hidden files as well. Whatever the files which are started with the dot here that are hidden files, it includes the hidden files also. The dash represents that human readable format. Otherwise this 4 KB and things will be shown like something 4000, and I don't want that to be happen, so I kept H. So if you want to see the man ls, you can see all the flags. Like if I use F, I can see list all the entries in the folder. So yeah, this is what basically, like, just you can use the man command to read the entire detail about that particular command, and followed by I'll type pwd. It will print the present working directory. Right now I am in the home directory praying, and if I want to create a directory, I can use make directory linux demo. Now I can, if you see that linux demo, yeah, now the linux demo directory is created. Do you want to go to the linux directory? You can go to linux demos, change the directory, cd represents change directory, and linux demo. I'm going to the linux demo. If I do ls, there is no file or directory which is there inside the linux demo right now. And another command is echo, which is a print statement of linux terminal. If I do linux, it will print linux. So this is echo, and I can create a file using the command called touch. With that I can create a file test.txt. Yeah, see, test.txt is created. If I want to open the file, I can use cat test.txt. Right now there is nothing, so it doesn't print anything. So I'll just open that test.txt. This is second line. Yeah, now if I open the test.txt, you can see there are two lines. This is first line and this is second line. There is another important, like this is not important, this is the funny thing. Instead of cat, if I use tag, it will be printed in a reverse order. See, the second line is coming first and the first line goes second. Like there is a small typo in it, just leave that for a while. Like the context is clear. Like, so this is some of the things that we can do with file creation and things. And also I can use some other operators and things which can make even more interesting. Like I'll cover those commands and things in the upcoming slides. If I want to remove some particular file, I'm creating a del.txt. You can see del.txt is there. If I want to remove that, I can use rm del.txt. It will remove that del.txt. There is no del.txt, but keep that in your mind. Remove, if you are removing something via terminal, there is no way to retrieve it back. So you have to be very, very careful when you are running rm command in your system. And if you want to safely remove and you want to keep some recycle bin data, like you can use the UI, which is you can use the UI like this in the Ubuntu system. It will keep there is a thing called trash, in which all the deleted files and things will be present for a while and then it will be deleted. So when you are using rm command, you have to be very very careful with the command. We have covered everything in this slide right now, I think, and we have created the directories, and there is a redirection operator also. If I open here, there is a print statement, right? This is redirection operation, and I'm storing that in a file called redirection.txt. See, now new file is created in the name of redirection.txt. If I open that file, the output of the previous command is present inside that redirection.txt. So basically it just override that redirection.txt with the thing which we are given in the double quotes. So this is what it is. If you want to append that like file, for example, if I run that same command, this is 2. When I use this one, I am catting it. It just override that same command. This is redirection operation is overridden with this is redirection operation 2. So if you want to append that file, you have to use double quotes. Sorry, double greater than symbol. Basically, that will append that file. Basically, if I cat right now, see, it didn't override that file, it basically appended with that file. So this is the help of redirection operation. As I said earlier, the rm command is a very very dangerous command. Like if you are deleting, there is no way to retrieve it back, and unless if you have some version control like Linux, like GitHub or something. Yeah. So this slide also covers the same thing like we have been talking about. That redirection operation, as I said earlier, this is used to redirect the one output of command like to the next file or something, and this is the append operation which is used to append the existing file. And there is one more thing called pipe. The pipe is basically nothing but it just gives the output of the first command to the second one, and second command to the third one, third command to the fourth one. Like it can go like a chain. So as a like if you remember, we have discussed earlier that Linux has one goal that one program should has one task to do perfectly. So right now we know that ps aux command, right? So basically it will just give all the like processes which are running in our system right now. So I'm just giving that ps aux output to the grep. Grep is basically represents global regular expression. It will search for that regular expression called something. Right now I'm gonna search Chrome. So when I type enter, this ps aux output which is present in the above will be given as an input to the next one. So in the next one it will search for the Chrome, and it will print all the lines which is having the line like word called Chrome. When I hit enter, you can see the highlighted red color text, that is Chrome, right? So the first output is given, all the processes which are run by Chrome is listed over there. If I want to count the number of lines in this particular thing, I am using the same command ps aux followed by the pipe symbol. I am giving that output to the grep, and followed by I am giving that output which is there in the above one to the word count. Word count basically count the number of lines, number of words. We can use whatever we can count whatever we want. Right now I can count the number of lines which is there in it, so that I can see the Chrome itself how many processes it is running. Right now Chrome alone running 22 processes in my system. So that is the beauty of Linux. That is the beauty of bash basically. So even if there is a very large number of files to process the large number of millions or billions of logs or something, you can process it in a seconds. So it can process in a very efficient way. and very fast way also. So that is one of the main reason that people are so much fascinated towards this bash and things. Yeah, so this is what it is. And so we have been seeing this commands running terminals and things like that for a long time, right? But this can be done even more faster way. Like so, even when I was doing the demo, but even though I'll just show you again. So I've been running a lot of commands, but I want to run the previous command which I ran. If I press the up arrow, I can see all the commands which I ran earlier. I can press the down arrow to go next previous kind of. So this gives us an option to do that, and this is one of the shortcut. And there is another way, that is autocomplete. Autocomplete is nothing but basically there is a redirection.txt, right? I want to read that. So as you know, cat is used to print that particular file. So when I do cat followed by, I don't need to type entire redirection.txt. I just need to type 1 or 2 characters followed by, if I press tab, it will autofill that entire thing based on the availability. If I do cat followed by re followed by tab, it just fill the text. If I want to do that same thing with test, if I want to press ts followed by tab, it just autocomplete. So this is one of the very important tasks. It reduces our work a lot. Like this seems little like very small shortcut kind of, but it helps you a lot when you are working with large data. And you can do reverse search as well, like because when you press Ctrl plus R, there will be one prompt it will ask for search. Like when you search for a specific command, like in my case I just search git, I can see all the commands, git commands which I ran earlier. See, I can see. When I do Ctrl R again and again, it will search for all the commands which I ran earlier with git. So when I type enter, it will give me that particular command output. So this is the help of reverse. I can run the command, like I ran make directory, right? When I search for mkdir, it will give me the output like I ran already Linux demo creation directory. So that's it. And followed by, if I go to my presentation, I can see the history. So what is the help of history? I can show you. I'm just clearing the terminal. I forgot to tell you about this. If I want to clear my screen, I can write clear, it will clear my screen, or else I can use Ctrl plus L, it will also clear my screen. So keep that in your mind. And right now, if I type history, it will give me all the commands that I ran so far in my system. So if you see from the session start, if you see all the here where we started, right? So from here, all the commands whatever we wrote in the terminal is present over there. If I want to run a specific command which is there in a specific line, for example, if I want to run the 1981 command, I have to give the dollar symbol 1981, it will run that command. You might like see the ls command is ran. You might think like this might not be useful, but these commands are very small, so you might feel you can type on your own. But when you start working on Linux for a full-fledged way, like you might run a command which is hundreds, thousands of characters might be. So during that time, for running that command, you can use the history to find that command like particular code, and you can run that. That is a very fast and easiest way to run that thing. Okay, so that's it. That's it about basically the bash. And the next part of the presentation we are going to cover is automation. So before that, I have to show you some other commands as well. So the next automation part, we are going to do health checkup of our system daily morning. 7 o'clock, like, which is an automated way. It will gives us the response that your system's health basically. So to check basically, if you want to see the memory RAM which is available right now in your system, it's a free command. It will check your RAM, what is the RAM of your system, and RAM in the sense memory, how much memory it is utilized right now and how much is free. These details will be shown in the free command. So just remember this command for the upcoming thing. Free basically gives the memory information, and df basically gives the disk related information. What is the amount of disk that we have mounted and what is the availability of that disk, and these related will be given by df-h. It's -h is human readable format. Like if I just give df, which will gives in a bit value, byte value, which is not readable. So for the human readable format, we are using -h flag, which will gives us the AMP-GB format. And also there is a command called uptime. Basically it will tells how long our system is awake, and like the system load and details, everything will be given in that uptime command. So we are gonna, if you want to check this entire command daily morning and you have to report that to your manager for a specific server, how it will be. Like daily morning you are coming to the your office, and you are just running these commands in your system, and you are just drafting an email to your manager, says that our server is using this much memory right now, this much storage right now, it is about to fill. So these things are little harder, right? Like what if there is a way that we can automate that entire thing, like daily morning 2 o'clock or 3 o'clock, which will run this entire thing in a single stretch, and it just get the output and drafting an email and sending that to your manager. So that is what the automation is basically like. So it will reduce your task drastically. So that is what we are gonna do. Like we have been seeing running commands in a one by one, right? So there is a way to run a command in a bash script. So bash script is nothing but it is a combination of commands which we ran already in a sequence of way. It will execute those commands in that same sequence. There are various things that we can do with the bash. Like basically it is like an entire programming language kind of. Like it has for loop, it has while loop, it has conditional statements like if else, it has switch cases, it has variables, loops, everything is there basically. You can use bash script to do that entire automation or run the entire script. So right now we are just gonna check the system health. I'm just copying that command and I'm just going to the terminal and I'm clearing the screen. If you check right now, there is only 2 files in my Linux demo directory. I'm just creating another file called health check, followed by .sh represents, this is a script, shell script. So if I do enter, I can see that health check.sh is created. When I open that health check.sh, there is nothing. So I am gonna paste the thing which I copied from my presentation right now. There is nothing. Like the first one is bin bash. This is called shebang. Shebang is nothing but it just tells the executor that to use this particular interpreter. So right now we are going to use the interpreter called bash. So it will go and look for the binaries bash and it will execute these commands. So the first statement is echo. It's just a print statement. It just prints server health and followed by 3 print statement. And df, you know what is the disk availability it will give, and free also, you know, it basically gives the memory availability, and uptime also, you know, it tells how long our system is awake. And if I save that file, if I want to execute, to execute that file, I can do dot followed by slash health check. You are seeing the permission denied, right? Do you know why? If I do ls-la, it has a read access, write access, but it don't have execution access. So I have to give the execution access. So to give the execution access, I have to give change mode to the execution for the health check. If I do ls-la again, you can see it becomes green, and also it is executable. So whatever which is there in a green color, it represents that is an executable file. So now if I run that same dot health check, see, I got the output. I got the output of 3 commands together. It gives me disk information, it gives me memory information, it also gives me the uptime, how long my system is awake. So this is what the scripting is basically. As a first step, so our intention is to run the daily morning 2 o'clock, right? So as the first step, we completed that running that particular thing together as a script. So basically it runs all the three commands together in a single time. Our next step is to run that on a specific time. Here it where one important thing comes cron job. The cron is nothing but it just keep on looking for a execution like in a specific time. So there are various things which are present for the cron. Like I'll just tell you how to execute that file which is created by us right now. So if I go to cron tab -e, it basically open the cron tab of our system. Cron tab is nothing but it just execute a file in a specific time, or execute a script which is in a specific time. When I open that, there is a typo. When I open that, I can see there is one example. There are 5 stars in it. That 5 stars represents different things. For example, first star represent minute, second star represent hour, and third star represent day, in which day, in month, and the fourth star represents month, and the final star represents in weeks which day. 0, 1, 2, 3, 4, 5, 6 till it is there, like week has 7 days, right, in which day we have to run. So similarly, for our intention, daily morning 2 o'clock, this particular health checkup should run and should give the output. So in our case, 0 minute of 2 hours daily every month, every weekday it should run. And before that, we have to locate the file, right? So right now our health checkup is in which directory? I have to copy that, and I have to give the path followed by the file name. So I have to redirect that output. This you know, right? This will append the output to the healthcheck.log. So right now it is installed. So what it will do, daily morning 2 o'clock, it will go and check, it will run that script, and it will redirect the log to that health check.log. So right now if you see, there is no health check.log because it will execute only at 2 o'clock. So to modify that, if I open the cron tab again, we will run that every 1 minute once. So now every 1 minute once the cron tab will be executed. So to see that, let's wait for a minute. Right now 10 like 12, the time is 12:22. We will wait for 1 minute. Yeah, now if you see, there is a thing called health check.log. If I open that health check.log, see the server health check is there, and the time also there, and every other details also there. So this will execute 1 minute once. To check that, we will watch that frequently with a health check. So this will gives us the last 10 lines, followed by it will keep on watch for any change in that file. If anything changes, it will print over there. So right now 10:23, if I see every 1 minute once, it will execute that file. So we will wait for another minute to see the output below. So that is what the power of cron job basically. See that 1 minute is done, again it executed that file and it gave the output. So right now we just checked it, what is that current health status of my particular server or my system. Like we can configure the SMTP email service with our system, so that it will basically check the system health, and it will draft an email in the same script itself, and we can send it to some particular destination email address. So that can be one of the task for you guys to do. Like basically that is very simple in that AI era, because if you just give a one prompt to the AI, like how can I automate, this is the script that I have, how can I draft an email to one particular destination email, it will gives the output like how you can configure the SMTP of for your Google email or something, and with the help of that you can send an email also. It is an automated way. Daily morning 2 o'clock it will directly send an email. So again just 1 minute over, again it is giving the output. So it will keep on generate the log. So I don't want that to be happen, so I'll command that cron tab. I don't want that to run forever, so I'll just comment it and I'm saving it. So this is what the power of cron job that we can do with. And if you see Linux right now, it is everywhere, like including software development in the sense like when you are building one software, like you might do this continuous integration and continuous development. During that time also, like you will use Linux everywhere, like GitHub Actions, or there is one more thing called what is that? Okay, basically GitHub Actions is using that, and there is DevOps related people who are all like DevOps is entirely, if you ask me, everywhere. Shell scripting is there. Linux is a very important thing over there. And if you ask cloud providers, the servers and things, everywhere it is running Linux. And cybersecurity, as I said, to process the large volume of files, as well as the large files like millions and billions of lines files, with the powerful tools like AWK, grep, SCD, and so many files and packages which are there in bash itself to learn. So with the help of that, you can analyze the logs easily. And when it comes to embedded systems, the routers and networkings, even in there also it plays crucial role. And if you see the robotics, in robotics part also, I have seen a lot of consoles and things which are using Linux based kernel, and they are just customizing depends on their needs, and they are using it very efficiently. uh, yeah, so again I'm saying, if you ask me, Linux is everywhere. So this just terminal is not just a place to type a command, like it's an entire way to completely control your machine. So you don't need to memorize an entire commands and things which are required to run. Like, you just learn the commands which are necessary for you, and later part, when you need for a specific purpose, during that time you can learn about some particular command and you can execute those. So start with your curiosity, and just open your terminal and explore a lot. Like, you can do a lot with it. And thank you for your time and being with me. And if you have any other questions or something, please feel free to uh, post that in the chat window, and me and my team is sitting behind, and we'll try to respond to your questions. And also, if you want to reach out on us, just reach out at support@redirection.org, or helpdesk@redirection.org. Thank you.